back for the second session of AWS DeepRacer today. So hopefully some of you have been for the first session, which was getting started. In this session, we're going to go deep. We're going to go advanced topics with DeepRacer, how to make your car go faster. And I'm absolutely delighted to be joined by Lyndon. So Lyndon, can you introduce yourself, please?
Hi, I'm Lyndon. I'm founder of the DeepRacer community. I'm also an AWS machine learning hero. And on the sideline, I do data science and machine learning consultancy.
Awesome. And if you want to follow Lyndon, there's his Twitter handle. So make sure you do. He leads the DeepRacer community. And if you want to know anything about DeepRacer and how to improve your time, he's always there to help people. So in this session, what we're going to do is we're going to really cover going beyond the basics of creating your first model, and then sort of diving deep in how you approach improving your time, what tools and techniques you can think about, and then opening up really for kind of Q&A where we can hopefully answer any questions that come up. So I've already introduced Lyndon. I think what I like here is to try and introduce it from the point of view of best times. So obviously Lyndon is beating me there by quite some margin there. So this is what we're going to cover today. So the first section is how to create a good model. Okay. So what do you need to think about to do that? Then we're going to follow that with some of the common pitfalls that we see people taking, and also some of the pitfalls that we've learned from things like the DeepRacer community. And then finish it off with some of the tuning and tooling that really we think are essential to you improving your time. And then wrapping up with some Q&A. So we'll try and keep this very informal, very conversational. There's not really that much slideware. So without further ado, let's crack on.
Great.
So creating a good model. Okay. So we're going to talk about, first of all, is choosing your strategy. And I want to kind of give a hat tip to Thomas here, who has got an amazing blog, Code Like a Mother. I'm not sure if that blog the link is in the chat. If it isn't, I'll put it in there. Okay, but he's got a really great section around choosing the right strategy for your model. Lyndon, can I ask you, from the point of view of how you approach this, choosing your strategy, how do you approach this?
So it is quite different when you're racing for the physical races and for the virtual races. And so I guess if we focus on the virtual races, there's been quite a few of those over the last few months. And my strategy really there is to do a couple of things really, is to think about what is the shape of the track, how long the track is, and what are the best sort of action spaces through there. But ultimately it's about getting around as quickly as possible. And one of the great things with the virtual races is you get lots of chances to try again through the process. And that allows you to have a bit more of a flexible strategy to try and push in the limits, whereas in the physical races at the summits you get 4 minutes, which is fantastic, but that's quite an intense period, and so you want a model then that works quite well, and that changes the approach in terms of training.
So what we're saying is that if I'm going to go with one of these things, if you're not going to do that, then actually you have a different strategy to how you create your reward function, all that kind of stuff.
Yeah, absolutely. Yeah. So for the physical races, the environment is unpredictable. There's obviously lighting and shadows and people around the track, and so the camera gets a feed which has lots more noise in it, and so you need to make sure your model is a lot more stable and able to adjust to a lot of the unexpected elements, and so that requires training your model to be a little bit more aware of different possible backgrounds. Whereas in the virtual world, obviously, it's the virtual world, it's the same world that you're training in, and the graphics in there are great, but it's also consistent, and so the model can become more dependent upon what it's trusting and seeing in the process.
Yeah, okay, and I think it's good because as data scientists, I don't classify myself as a data scientist, okay, but when I speak to data scientists and when you speak to people who work with analytics and big data, it's really important to start off with the goal you're trying to achieve. Okay, so in a way, your goal, whether it's to be the fastest time in the virtual circuit, the real circuit. One of the things we didn't cover in the first session was that we also have a number of these. I think they're called weekly challenges as well. So these are challenges not necessarily around getting the fastest time, but they might be, for example, getting a specific time around the lap. Okay, so these are all specific objectives you're trying to achieve, and so starting off with that will help you then map out, what your action space should be, what your reward function should be, maybe even what hyperparameters you would take,
right.
And then also what tooling you would then use after that.
Yeah.
Okay. So once you've chosen your strategy, okay, how do you track your progress? So what can we learn from the community? What can we learn from you as to how you track your progress so that you're getting better, rather than how some people, when I've talked to, they feel like they're going nowhere and they're actually getting worse.
Sure. I guess you kind of have to think about it's progress for you, and ultimately everyone wants to win, but there's lots of people competing. So you just kind of need to look at what you're doing, what you're trying to achieve, and how you're getting there. And so, as we saw in the previous session, the console gives some tooling, some graphs, some information that allows you to see a little bit around how your model is progressing through the training. But underneath that are lots of logs, lots of detailed data on what the car did, to an element of why it did it. And if once you get into the real understanding and depths and trying to understand that, it gives you a lot of information around there. But broadly speaking, is your car getting around the track is a good indicator of progress? And is it getting around in a time that seems to be improving? That doesn't mean to say you have to get around the track every single time. You don't need a 100% completion rate to take part, but you certainly want to get it so it's stable enough that you can get some laps out of it.
And I definitely echo that. I mean, I tend to use the model where, as long as the car is going round maybe 2 out of 5 or 3 out of 5, it tends to be good enough. And it's worth risking a submission to the virtual league just to see if it will actually make it.
Of course, I mean, there's no cost in submitting to the virtual league, so giving it a go is what's the worst that can happen? It doesn't get around, and you've lost all your chances in the process there.
But so one of the things I've learned, okay, and maybe people on the chat can maybe share how they approach this, but I know it's something that has been talked about in the DeepRacer community on Slack, is that when you're doing all these experiments, okay, it's really important that you track, because there's lots of variables, there's lots of moving things, okay. So how do you know whether changing a hyperparameter from A to B made this impact? Okay, so I use a good old-fashioned spreadsheet. Other people I know have been using kind of markdown documents in Git. But I think the point is, though, keeping a track of what you're changing and the impact on time or the impact on the goal is really important. So how do you do that yourself?
So I like you say, keep a detailed log, because it's very easy in the moment to get dragged along to do the next training session and everything else, and kind of look back and say, how did I end up down this line that it's performing now? And maybe if I went back to an earlier point and branched my strategy differently, it might have a different outcome. So similar to you, I keep an Excel spreadsheet of everything I've done, each training session, how long, what settings I used. But of course, you can always go back to the models themselves and see what did you configure in there. But it's that basic sort of notes on what was I thinking when I tried that. And so when you see it, of course, you can try it more and more times, but obviously the more and more times you try, then obviously the higher the cost in terms of it. So you need to have a little bit of science to your approach, so you don't end up exploring every possible outcome.
Yeah, I think that's a good point. Okay, I think again one of the reasons to do this is so that you optimize the time in the environment, so you don't end up spending too much money. Yeah, absolutely, good point. So if I can maybe somehow get out of you what you think are the characteristics of a good model. Yeah, we've got 2 things there. Action space and stuck in your rut. So to spill the beans, because everyone wants to hear.
Okay, so I'm not going to tell you all my secrets, but I still want to win the current races. But no, in all honesty, what for me makes a good model is it's showing progress towards your goal. And so if your goal is in the virtual environment, that actually you're seeing improvements in your time, you're seeing you're able to get around the track, and that it is stable enough to give you some good insights. I mean, ultimately, you're learning from this, and so it's as important to be understanding what's going on and why your idea probably didn't have the intended outcome that you expected. And so a good model for me is one that ultimately has helped me learn something, but is also helping demonstrate that it's going somewhere and it's getting better in the process. So looking at a model that has been training for a while, that it is essentially getting around the track, it's getting around all bits of the track, is obviously a key part of that. And looking at the path it's taking. So when you want to start getting the faster times, obviously you have to start thinking about not just following the center line the entire way around, which will give you a nice stable model, but actually it's wasting time on some of those corners and some of those bends.
Yeah, I think that's a really good point, actually. I think some of the most innovative ones I've seen actually are maybe not, say, taking the center line, but maybe using the center line and then the outer line as the marker of where they want to be to take a better racing line, perhaps.
Yeah.
Okay, cool. Right. So we've done kind of the strategy around the goal, how you identify your strategy, and then so we've talked about these kind of key areas. Now, with the monitoring your progress, we've talked about how you keep a record of the information yourself through spreadsheets. But I think one of the key things really, and we're going to dive deep in, is using some of the tooling we have, such as the SageMaker notebook sort of tool, with either the one that we provide or one that the community has developed over time, led by Thomas and others, that really help you extract the information that is recorded as the virtual car is going around the track, to then really help you understand what your model is doing, and then understand how to improve the reward function, or tune the action space and the hyperparameters. Okay, so we're going to talk about some of the common pitfalls next. Okay, so once we've got a plan, we know what we're doing. Now we're going to come into some problems, right? Everyone, when you look at the community, we've all been here. So let's talk about some of the more common ones. Okay, so the first one being convergency conundrums. Okay, so what do we mean by this? What we mean by this is that as we train our car, okay, it doesn't seem to get any better. And what we mean by that is it doesn't seem to be completing the tracks. Okay, so in that graph I showed you in the first section, we want to see that nice graph go up towards the right in completion. We don't necessarily see that. Okay, so what tends to be kind of like, in your experience, some of the problems here?
There can be a number of reasons why your model isn't converging. And again, to be clear, convergence is that your model has got to a point where it's stable and is performing as best as it's going to get, given the configuration that you've set it.
Yeah.
And so if your model isn't converging well, then it's probably back to one of those core elements. So maybe you haven't got the right action space. Some of the more recent virtual tracks have had quite sharp bends, and of course, if your steering is only giving 10 degrees steering, it's never going to get around those bends, and so that's going to be a problem. So, but equally, like if you have a big action space, then that's going to take a long time to actually train, and so it's having to explore, maybe 10, 15, 20 different actions. And it just isn't clear to the model which is the best one given the current situation. Same for your reward function. Maybe, I've had situations where actually I've inadvertently been rewarding for behavior that I hadn't expected. And so on some of those bends, I was rewarding driving straight up the track. And so the model thinks, okay, that's apparently the good thing to do. And of course it then crashes, and then it gets a bit confused in the process there.
So that's the Cobra effect.
Right, exactly, yeah. But the log analysis, as you said, helps you understand. You can go in and you can start spotting why is it doing that, and you can have a think through, looking at your code, looking at your action space, and trying through those.
Cool. And we're going to show that. We've actually got a good example of a car doing exactly that. So we'll everyone who's on the Twitch will be able to see that. Okay, so we've got stability versus speed, and we've talked a little bit about that already. Okay, so this is the whole concept that actually, do you need to be 100% stable all the time, or actually are you more focused on speed?
Yeah. So I think in my virtual models, my models are really unstable on purpose. So I started initially by having models that would maybe get around the track maybe 4 out of 5 times, maybe 5 out of 5 times, and that was great, but they were slow. They were sort of at the sort of 20, 30 second mark. In the virtual world, because you have so many chances to try and submit into the league every half an hour, you can afford to take more of a risk. And so my models that are doing the best speeds actually purposely try and take the corners quite tight, and most of the time the car will go off the track, but maybe 1 out of 5 times, 1 out of 10 times it'll get around, and when it does, it gets around really fast. But that's a strategy that works well for the virtual environment. But of course you can push it too far, and then the model won't converge and won't train because it's crashing too often in the process there.
Okay.
But similarly for the physical races, that just doesn't work. You need a model that is really stable. And actually speed then is less of a concern. So the model that I use at the London Summit, which got me 5th place, in the virtual world was getting around the track in 30 seconds plus.
Wow.
But it was really, really stable.
Yeah.
And then when I went on the real track, because you can control on the car the maximum throttle and through the actual car's console, I managed to push the car to just 9 seconds off the back of it.
Awesome.
But only because it can get around the track.
Yeah, cool. And actually, kind of related to that is kind of like the overfitting, challenge, which is where you train your reward function, your action space so much, that it can work on just one track. But then when you try and deploy it on one of the newer tracks that we release every month, it hasn't got a clue. So talk to us a bit about that.
Yeah, so overfitting, as you say, is when the model has got too used to the environment and it needs to have exactly the input it's expecting to do an action. And if it gets input which it has not expected, it is really unclear and it will then kind of probably take the wrong action. So in an ideal world, you want your car to be able to drive on any track in any situation. And of course, then overfitting is always going to be a problem. You don't want that. But in a virtual race, actually, sometimes overfitting is a good thing because, for each individual track, with the way the races are currently set up for, if your model knows when I see, for example, that tree in the background, I turn a bit sharper left. Then is that a bad thing? If it gets you around a little bit more consistently, a little bit faster, then that's it. But who knows? I expect the race is going to get more and more complicated over time, and so overfitting will be something which will be tried to be ironed out the process. But for the moment, actually, it's not necessary.
So it's one of those things that actually may be a problem, but actually can be used to your advantage potentially.
Yeah, it depends.
And I think it's important because now every month we are creating new tracks, and those new tracks are more complicated. They've got more distractions, let's say, and so. If you have overfitted or overtrained your model, then there is a danger that you have to start again from the scratch.
And of course, one of the other good things you can do is you can train your model on multiple tracks incrementally, and so you can actually teach your model out of some of that behaviour, and that kind of comes back to not just changing your action space and your reward function, but also thinking about your training strategy. So which tracks for how long, how much, and of course, if you spend all of your time on just one particular track, then it will almost certainly overfit to that track. Whereas if you share it amongst similar tracks, then it will become a more resilient model that can do more things.
Cool. And then the final pitfall is this virtual versus physical. So now we've talked about some of those things, but the one thing we haven't talked about is that actually the virtual simulator is an approximation of the physical thing. So that real sim kind of like issue potentially is there. So have you seen problems? You mentioned already your 30-second model going around much quicker than that. Are there any other things that people need to be aware of?
I wouldn't describe that as a problem, by the way. No, I was quite happy when I did that. But no, you're absolutely right. So the virtual world is obviously based upon the nice environment it's been designed, but at the trackside, at the summits, and even at the meetups that we're organising, the barriers can be slightly different. There can be different lighting, even people's shadows falling over to the track. And at the physical summits, you tend to have one of the AWS pit crew chasing your car around for when it falls off the track, and even their foot might be getting in the picture and things like that. So you can never train for those things. It'd be impossible to build a virtual environment that has all of those characteristics. And so this kind of comes back to that overfitting thing. If the car is absolutely certain, or it needs to see a very clean track with a very clean background, because it's just overfitted itself, that's an issue. So for the physical races, you do need a model that is experienced on obviously the reInvent track, given that's the current one that's being raced on, but dabbling into some of the other tracks just makes it a little bit more resilient to the unexpected. And ultimately, we want to teach it to focus on what's right in front of it, which is the track lines, the shape of the road, where it's going, and to ignore the background and everything else, which ultimately isn't really helpful.
And I think when we had one of the first meetups, what was interesting is we didn't have a particularly good barrier. And a lot of our models were struggling on the cars to go around, weren't they, because of that? So that's one of the real issues we see. And actually, just as it's probably a good time to mention for anyone who's in London next week, I think next Wednesday, we've got a meetup, a DeepRacer meetup here at the AWS office in London. So go to the community and get more details. And if you can make it, then we'd love to see you there. Set one up all over the happening near you, then go to the DeepRacer community, and I think you're creating channels for everyone, aren't you?
We are, yeah. And of course, if there isn't one near you and you want to run one, then again, come to the community. I'm sure we can help you with the logistics and everything else to get one up where you are.
Cool, excellent. Right, so let's go into the last bit, which is tuning and tooling. Okay, so what we're going to cover here is really kind of like, we're going to probably go off the presentation now and go into the actual code. And we're going to look at the actual reward graph, then dive into SageMaker. Lyndon's going to talk us through one of the notebooks that pretty much most of the community members are using really to help understand how their model is working. And then we'll kind of go through some of the hyperparameters that we think are important, and then finish off with some of the resources that we feel are really useful to help you go. So I'm going to go out of this now and go into the console. So I already kind of introduced the reward graph when I was doing the first one. So we've seen. So this is the reward graph. Okay, and actually, if I look at another one, which actually is probably better, this one here is, I think, slightly better. You can see that we've got this kind of graph. Okay, and actually, this has changed over time, and we can actually not only just show the average, but we can actually show individual amounts as well. Okay, now this is useful to a degree, right? But it's only kind of superficial, I guess.
Sure.
It will allow you to see whether you're in the right path. And if I show you what some of the ones that look like that aren't necessarily so optimized, I think this one here, for example, you can see this one here is not really. It's not happy. So it's not a happy one. This one, okay. So you can use it at a very kind of like high level to know whether something's going in the right direction. But really, what you really need to do is get access to the logs. Okay.
I'm just going to say, I mean, on this, the reason why it's not happy is we would expect to see the reward getting better over time, and of course, all we're seeing is jumping up and down continuously. So that's not a model that's worth continuing with, because it's not learning anything useful.
Correct.
And it's also the number of times it's getting around the track is obviously quite low. It's around, well, I guess 20% or something on there.
Exactly. So exactly. And this was an experiment to just create a graph so that I'll show.
This is not your base model.
Exactly. Yeah. So I mentioned it in the first session. How do you access the logs? Where are they? The good thing is that every time you create a model, we have access to the information here. Okay. Now, whether you want to access them directly in CloudWatch or as what we think is a better way of doing it is going through SageMaker to do this. So let's do this, shall we? So if I, I'm not sure what's happening there. So let's make sure I'm logged in. I am logged in. So when you go into SageMaker, there'll be a notebook instance which you can start up, which I've already done, and actually before we start, let's actually find out where you get the logs from. Okay, so if we do DeepRacer log analysis, okay, there is a couple of places you can get this. We've got it in the DeepRacer one, but we've also got it through a repo that Thomas has, who I think he's in the chat. So Thomas, I'm not sure if you can post a link to your notebook, but he's published like a kind of a community version, okay, which actually that's not the community version. This is the AWS one, which you can go to and you can check this GitHub repository out. And here is the SageMaker notebook that we're going to be using later on. Okay, so this is the AWS one, but we also have the where is it? Is it somewhere here? Where is it?
Be in there somewhere, but we'll get Thomas to post it on the chat.
Yeah, well, it's here somewhere, but the process is the same. Okay, so what you'll do is within SageMaker, what you'll do is you'll go into a terminal. You'll do your Git checkout. So if we do,
there we go. Thomas has posted it now.
Yeah, that's right. Thank you, Thomas. Okay, so you'll use your Git clone here, and then it'll copy the notebook project in here, and then you can load it up. Okay, so I don't want to spoil everything. So when you load it up, this is what you get, right? A couple of things that probably to be for people who have not done this. The first time it might ask you for the runtime environment. So it's Conda TensorFlow P36, and also the notebook might have information already in it, so you want to clear all that stuff out. Okay, so you do a kernel reset, restart, and clear out. I'm not going to do it here because of the purpose of saving the data. Okay, and then the way that Jupyter works is it has these little blocks. Okay, and like a debugger, you step into every block and it runs the code that's in the block. Okay, so some of them are text where there's no code. It's just to help you understand what's going on. Some of them, like these ones, are actual code, and you can step into it and it will actually run them for you. Okay. Now there are a couple of things you need to do before you set this up. So the first thing is you'll need to set up permissions on S3 so that the SageMaker notebook instance can have access to say the S3 buckets and CloudWatch to get the logs. You need to install Shapely as well in this instance as well. I've commented it out. But once you do those things, okay, there might be some initial setup. Again, the community has got a channel direct. It's just for log analysis, and a bunch of us are in there, led by Thomas and a few others, helping really kind of lead that effort to make more people learn it. I think also there's a challenge, isn't there? At the moment?
We currently have a challenge this month in the content in the community, so for people to actually enhance and contribute to the log analysis. So that's running for another week, and people are adding improvements into here to feed back to the community.
Brilliant, that's really important. So if you are a Jupyter Notebooks expert, if you are a data scientist, and this is the first time you're looking at this, then please get onto that challenge and see how you might improve the
and honestly, even if you're not, it's more important actually for people who are fresh to it, who don't understand Jupyter
Good
Notebooks.
Point. Excellent.
If there's something confusing in there, something that's not clear, that we can make it easier, then that's as useful as a really good scientific algorithm.
Excellent. So let's walk through this, okay? What it effectively does is it loads a bunch of libraries. It sets up the track that you want to analyze, and then the first thing you'll notice here is it asks us for a stream name, and this maps to the sim name here. Okay, so where was I? So this is how we know. This is how we connect the notebook with the logs of a particular training session. Okay, it then brings the logs down. We can make sure that the logs look okay, and then we can start doing stuff with it, right? So talk us through some of the things that you, Lyndon, would typically look at.
So what we saw on the console graph was just a simple, what is the reward over time, and also how often was the car getting around as the training progressed. And that's a good place to start, but it's not going to tell you why and where you could go next and what you could try, and really what is causing the model to behave in ways you didn't expect. So this is where the Jupyter Notebook has got lots of different ways of crunching that data. You can look at the raw logs yourself, but you really trying to get you visually to see that. So what we're trying to do is introduce a number of different graphs. And so when I'm using this for my training, and there's some basic things I'm looking for. Similarly, again, how often is the model getting around the track? And again, it hasn't got to get around it. So in this example, the chart at the bottom right-hand side there is showing most of the time this model is doing well and getting 100% around. Of course, there's quite a lot in there where it isn't. Now, that's not a problem because the car purposely is exploring the environment to see if it can find a better, higher reward earning thing. And of course, quite often it will crash. So you're not expecting to see an entire 100% off the back of there. And in fact, if you are, then you've probably overtrained your model and it's not worth training it much more.
And I think it's probably worth adding as well that I think when you're starting off with this, what I did is I experimented with lots of different models, good ones and bad ones. Mm-hmm. And then use this to understand how it would look like, and then see how I would actually know whether I was going along the right lines or not.
Sure. And then the other thing then is the lap times. And so you can see then in that middle chart at the bottom is what is the distribution of lap times for completed laps. And so you can see some are actually going really well. I think that graph is showing for all episodes. But there's different ways you can cut the data into just completed laps. And what you'll see is a long distribution of really fast ones and some really slow ones around a normal. And of course, when you're submitting to the virtual race, you're trying to exploit that statistical range. And the more often you submit, the more likely you are to get down the fast end. But similarly, if you're at sort of 15 seconds average, then you're still 6-7 seconds off. And so this model in its current state, it probably incrementally won't be able to get there. So there's something fundamental. And so you shouldn't be afraid about actually starting your training again. There is a point at which you say, this model is trained enough. And it's better to actually learn afresh than trying to get the model to learn and unlearn bad behavior in the process there. But for some of the partially completed laps, you can kind of see, or actually some of those would have had a really good lap time if they had just finished, if they just got over that last 20% around the track, for example. And the rest of the notebook then starts to help you drill into why that might be and what you could do to try and get those.
So let's drill into that, because I think there is a graph we've got here as well that helps us look at. We might have a problem, with one particular lap. Let's see if we can find the graph which we've got. Here we go. So one of the parts of the graph allow us to. Not sure I'm there. We can see here, for example, that the pattern of driving too fast and then not being able to get around that corner.
So what this chart has shown you, each of these red dotted lines is one episode. An episode is an execution through the environment until it crashes or gets around the track. So what you can see on this one then is that bottom right hand corner. A lot of those episodes are going pretty much straight off and not getting around. Occasionally it is, but mostly it's failing there. And so that's a really good example of where you can ask yourself why. And it may be your action space isn't suitable. It may be your reward function is incentivizing going fast and straight rather than turning. Now, of course, fast and straight is good for that bottom straight. But if your reward function isn't smart enough to know I'm on a bend, then that becomes a problem in the process. So you can start looking for the patterns and anomalies to say, I need to go and try something else. And you probably want to try a few different things. Suggest you try one thing at a time so you can draw out the result of that test.
I guess it goes back to the whole thing about what we talked about with strategy, choosing the strategy, how you're going to track progress, where you're going to track it, and make sure you systematically do that, so you learn something as you're going through. Okay, cool. So are there any other things in here? So I jumped ahead there. We've got some interesting graphs here. We've got a heat map.
The heat map was a good one to just touch upon.
So yes, this one's the heat map. Okay.
Yeah. And so this may look slightly different in some different versions of the notebook, but broadly what this is showing is for each step that the model took in the training session, what was the strength of the reward? And so this tells you two things. One, where is the car mostly going? And two, in terms of its position on the track. And two is, how am I rewarding? And so this is where you can combine, if, for example, you're seeing it continually going off the corner and your heat map is showing you've got nice high rewards for driving straight to your corner, then it's a good clue your reward function is probably not great. Actually, in this example here, which I think is one of the default ones, it's showing it's nicely rewarding going around, and actually the edges of the track are nice and black, so we're not rewarding much, and then the car isn't exploring there.
Exactly. It's not got great racing lines, this one, has it? So this is not going to do the best, is it?
This feels like probably a centre line follow model. Where
it could be. No comment on that one.
We'll see. But yeah, so the heat map over time then can see the adjustments through, and like you say, you want to find a good pattern through there and run that.
Cool, excellent. Right, so I'm just conscious of time. So I think just so people are aware, this is Thomas's blog. Okay, I think Thomas, the challenge is in here as well, isn't it? I think the log analysis challenge. So make sure as part of your strategy for improving your time, you check out this blog. There's loads of resources in here that will really help you dive deep into the logs. And as Lyndon said, no matter what level of expertise you've got, provide feedback. If you don't understand the logs, how can you feedback what you don't understand, and maybe even how can you change it so you can understand it? Okay, so we've got a week left of that challenge, I think. So go in and then that will help the broader community. Okay, so the last thing I want to talk about is the pit, if I can find it, in all these tabs. Right, is it the pit? No, it's not a pit stop. The pit stop. Okay, another resource, for you to be aware of, is the pit stop. So what we've got here is curated lists of things like blog posts, videos. We've got the log analysis tool. I believe Thomas's blog post actually is on here. We've also got a YouTube channel which has got a number of videos, DeepRacer TV, which I believe you and Thomas are both in, aren't you?
We're in the London episode, which is a really good fun time from May's summit.
Yeah, and actually the videos are very short. They're about sort of 18 minutes long. They're very well made, and actually each of them has got some really good content that will help you understand more and actually improve your times, I think. So I think there's 5 of them at the moment, isn't there? I think 5.
Ooh, I don't know, 5, 6.
But they're definitely worth checking out to kind of like, again, that will help you improve your own understanding to then feed back into better models, better reward functions. Okay, and then we've got some other stuff in there as well. Okay, so let's make sure we've covered everything we want to cover. I think the last bit of it is actually Q&A, leaving enough time for not that. So hyperparameters. Okay, that's the one thing we need to talk about, hyperparameters. Okay, so we talked very quickly about these. Let's have a look. Let's create a model.
So what we just did, so the hyperparameters are the way that SageMaker uses to actually optimize the policy training through the process, how it accounts for the different parts of the board, how it runs, how often it runs in there. And so there's lots of power you can play with in these settings.
There is, and so what? First of all, when you approach this, okay, what are the hyperparameters that you tend to focus on?
So I think as a complete newbie, and when I first started, it's fine just to leave these as the default. You don't need to know too much about them. These are really for you when you start getting more advanced and you understand what's really they're doing. You can then start using them to better improve your training. So the ones I mostly use are the learning rate and the discount factor are the two which I find most useful. Some of the others I've had mixed success with changing. I just still haven't quite learned and mastered some of them. But if I guess we focus on those two.
Yeah. So learning rate, if I understand right, learning rate is the amount of change we make to the network weights when we're training the convolutional network. Is that right?
Yeah. So over time, as it's learning, it doesn't completely reset its learning. It's just taking a small amount of that new knowledge and folding it in. So incrementally, we get better and better over time, and we don't end up losing some of the historical knowledge just because we had a couple of episodes that have taught it something which was probably incorrect. So a high learning rate here means it will take a lot of the knowledge from the recent cycle and update quite a bit of the model. And as you train longer and longer and longer, you obviously hope your model is getting better and better and better. So you don't want it to learn too much. You're looking for fine tuning, fine tweaks in there. And so lowering your learning rate down then is a lot more important. So you can just incrementally get it better.
Okay, good stuff. And a discount factor.
The discount factor is about how many steps into the future your model is taking into account when it's working out a reward. And this can have different impacts to you. So if you've got a really good reward function that purposely rewards exactly well wherever you are on the track, you probably don't need to look too far ahead, and you can have quite a low-ish discount factor, maybe taking about 10 steps ahead. There's a formula which translates that number into how many steps. So 0.999 is 1,000 steps ahead.
Okay.
And to give you some context, most of the virtual races, you're around sort of 150 to 200 steps through there. So 1,000 is way too much overkill. Right. You don't need to go that far.
So we know that the car's doing 15 frames per second.
Yes.
Okay. So the calculation is the frames per second plus the number of seconds to go around the laps. Roughly.
Roughly in the process.
Okay.
And then, of course, if you actually have got some nuances in your reward function which is imperfect, then having a higher discount factor. So it's essentially saying this step may be rewarding me poorly, but I know when I take that step, the next 10, 15, 50 steps are even better than getting a really short-term high reward now. And so having a higher discount factor there can compensate some of those things.
Okay.
But ultimately, it kind of depends. And so some of my models reward for the time it takes to get around the whole track, and so that ends up being a final thing. And for getting that to propagate through, you need quite a high discount factor.
Cool. Okay, so that's great. Thanks for that. Thanks for sharing that knowledge. So I mentioned in the first session we've got documents in the documentation around help on the documentation to tell you what these do. But the other resource that's really useful here again is the community. Okay, there is a reinforcement learning channel, and there you can ask kind of deep questions around the reinforcement learning piece, including things like hyperparameter tuning. Okay. Cool. So I think now for the last part, I want to kind of like open it up for Q&A. So do we have any questions, Lyndon, that we can address?
I'm just looking down the list. I think most of the questions actually, Thomas is doing a great job at answering them.
Fantastic.
Online.
This is what we like.
Yeah,
well done, Thomas.
Saving us the job. But yeah, is there any new questions coming through? I think I saw a question earlier saying you don't have to have a physical car. I mean, they are hard to get, and particularly in the UK and Europe, there isn't even a date yet for when these are shipping. If you're in the US, I think they're shipping now, but there's a big backlog you've got to work through. So, yeah, the virtual environment is more than enough to get you going and to get you learning about it. And maybe eventually you can get your hands on a car or come to one of the meetups where we obviously have cars and tracks available for you to borrow. And
I was just going to say that. I was saying if you want to see a car, then come to a meetup.
Absolutely.
You know, like I said, next Wednesday we've got one, and we're going to have a few cars there. I think
maybe 5-6 cars.
Well, actually, wherever you are in the world where there's a meetup, there will be cars.
Yeah, that's true.
Okay, cool. So nothing else we need to answer. If there's no questions, we'll be going through the chat anyway and answering. Again, I would recommend everyone join this community. The link is on the page there. Any questions that haven't been answered here, feel free to answer them in the community, where as a group we will all endeavour to answer those.
Absolutely.
I think with that, I'd like to say thank you very much for spending the time with us. Thank you very much, Lyndon, for joining me and sharing your wisdom. I will get those reward function secrets from you one day. I look forward to seeing all of you now go in, try and create your first model, then tune it, and then race it. So with that, thank you very much.